My Stirling single, Part 58, fitting the brakes to the locomotive was a surprisingly fiddly job and took quite a while to complete. The brakes on a Stirling single are more complex than I first thought, and looking at the construction of the brake equipment, I'm really glad that the brake gear was already made and just needed fitting. I have to say, whoever built this engine really did know what they were doing. The engineering standard is very high indeed. This is basically a very boring video. It depends which way you look at it. From my point of view, it wasn't boring, it was incredibly tedious. First of all, the injector piping was in the way of the rear wheel brakes, and the brake gear was quite dirty. I didn't clean it because it's just going to get dirtier once I've fitted it. This engine is not a new engine. It seems to have been steamed frequently by the residue in the smoke box and also by the dirt on the brake gear, which must have been fitted at the time. The wheels and the brake gear, as well as the chassis, were the only parts that were painted. A particularly difficult part of this job was fitting the rear brake block assembly on the brake hanger near the injector because the piping was in the way. Look at it, it's like spaghetti junction. But after a bit of careful manipulation, I created a space to allow me to fit the brake hanger on its mounting. I secured it to the mounting pin using a brass washer and a nut, which was secured using a socket like this. It's unusual for me to see nylock type nuts in BA sizes. I just found this particular one. The brake assembly is very ingenious. It's not what you think. It has a lever mechanism that applies pressure to the rear wheel first, and I assume this may be as per full size. Thinking about the mechanical principle of applying a brake block to an 8-foot diameter driving wheel is a bit scary. That's possibly why the braking system is as it is. Progressive brake the rear wheels first, followed by the big ones in the middle. I carefully repositioned the injector so that the piping did not touch the braking system. At this stage I would like to mention that even though I'm fitting the braking system to this Stirling single, it will not be functional. During the 1980s I spent an awful lot of time running miniature locomotives around West Riding Small Locomotive Society's track. At that time I had a very high pressure job in my recording studio, and this was the only thing that kept me sane. Here on the bench is the brake linkage for the other side. Why am I going to make it non-functional? In all the time I spent running miniature locomotives, I never used the brakes on the locomotive itself. If you're pulling a train full of passengers, there's no possible way that the locomotive is going to stop the train. All that happens is the wheels lock, then it skids down the track and wears flats on the wheels. Particularly bad on a locomotive with two very large driving wheels. The surface area and number of braked wheels on this locomotive would just make it a waste of time. The tender has brakes. There are 6 small wheels on the tender, but that's not going to stop the train either. The only practical use for brakes on a miniature locomotive is to put them on when you're raising steam. So if by any chance you've left the reversing lever in forward gear and the regulator part open, at least the locomotive will not move by itself. This brake gear is held together by split pins into 1/16 diameter holes. They're very small split pins and really fiddly to fit. I temporarily assembled one side of the engine. The cab has been painted and rubbed down, ready for the second coat. The cab windows in the spectacle plate have been blanked off using pieces of cardboard. This was shown in a previous episode. Here's a close-up of the maker's plate. This engine is number 170. It's a model of an early one because it has 11 slots in the splasher, and the maker's plate is dated 1875. That is of course for the full size, not this model. I'm going to fit the brake gear to the other side, starting by fitting this pin that holds the brake hanger to the motion bracket. I used a socket screwdriver for this. That was when I finally got the pin to sit in the centre of the brake hanger, which was more difficult than I thought it was going to be. I fitted a nut to the rear of the pin, and here I'm tightening everything up, using 2 spanners very gently. This unfortunately marks the paint, but there's a quick fix for this. It's called a toothbrush. I simply brush away the damaged paint. I will be getting the paintbrush out to paint all the split pins to stop them rusting, as well as touching up any damaged paint. The construction of this brake gear is extreme. I really wouldn't want to make it. I am not a machinist, and I admit that. I could make the brake gear for this engine, but it would not be as well made as what you're looking at here. Fitting the 1/16 of an inch diameter split pins was a bit of a challenge, but with the help of a pair of small side cutters and these very small long nose pliers, I could bend the ends of the split pin around the shaft. Now for another fiddly bit. The first thing I have to do is move the injector out of the way. The piping is very close to the brake hanger, and in this case it's too close. I'm rotating the special rod on the threaded bar to make sure it's in the right position before I fit this part of the brake gear. Finally, I managed to get the hanger onto the peg, and after fitting a brass washer, once again I used my very useful socket screwdriver to tighten the nut on the end. The next part of the job is to fit the special extra long pull rod assembly that goes in front and behind the main driving wheel. By now I think I was getting a bit better at fitting the split pins because this did not take very long. I've spoken a bit too soon because fitting the final 2 link rods that will connect to 2 levers on the main brake shaft seemed to be a good deal more fiddly than the rest of the job, but with the application of a lot of patience I got there in the end. This is a potential brake shaft. The only problem with it is it's slightly too large a diameter for the holes. It is 1 imperial drill size larger than 1/4 inch. I drilled out the holes to clean out the paint, and they are 1/4 inch in diameter, although when I looked at a drawing at Blackgates Engineering yesterday, the main brake shaft is shown to be a bit bigger. I bought a length of stainless steel rod 1/4 inch in diameter. I'll finish off the brake assembly in the next episode of this series. That's it for this one. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.